Okay, this is lesson 5 of module 7. It's titled Solving Radical Equations. And you know what a radical is because we introduced that symbol. There's the radical sign. This one means square root. This one means cube root. So we've been introduced to that. A radical equation technically should be one where there's a variable under the radical sign. So even though this is called solving radical equations, we will be using square roots to solve them, but in my opinion, they're technically not radical equations. But nevertheless, it's going to give us some really good practice with this part of it. We haven't solved equations for a while, so we'll work on solving equations. So here's an example of what we're going to be working with. So here's an equation. There is an x cubed term. Here's an x term, another x term, and then a constant term. So remember, when we solve these equations, we want to get like terms together. So if I have two x cubed x cubed, we'll say x cubed. Yeah, so if I have a 2x cubed plus 7x cubed, I know that that's equal to 2 plus 7x cubed. Okay, so when the variable part is the same, like in this equation, then what I do is I'm going to add or subtract, just combine the exponents. Exponents, not the exponents. The exponent stays the same because that's part of the variable term. What changes is the coefficient. Okay, so this would be 9x cubed. Okay, it's kind of like when you are doing addition. Let me pause here for a minute. Kind of like, you know, I'm adding two double-digit numbers. I got 32 and 47, and I want to add those two together. And so I kind of think of, I've got 3 tens and 4 tens, which is really 3 times 10 and 4 times 10, right? But I've got 3 tens and 4 tens, so altogether I have 7 tens in my answer. And then I've got these 2 ones and 7 ones, and that gives me 9 ones altogether. And so my answer is 7 times 10 plus 9 times 1, or 79. Okay, so it's the exact same thing. You could think of the tens as like x, and so we're adding copies of those. Okay, so some of you may feel pretty confident in this, but I know from observing papers and that people still make a lot of mistakes solving equations, and it's something that is really important and that you will, you know, you're going to continue using in all your math classes. So it bears practicing. So we've got this equation here. Let's look at it. And if you're feeling confident, I would encourage you to just go ahead and try it on your own, and then come back and watch the video of me solving it and see how you did. But we've got these terms, right? And if you remember, when this 18x term and this 9x need to be combined on one side of this equation. But in order to do that, we've got to get 18x out of these parentheses, right? So what we always need to do first is make sure we get rid of all the parentheses and get those terms kind of out of jail, so to speak. So that's going to be our first step. So let's see what we do here. I'll go to purple. So I've got x cubed plus 9x. Notice I didn't change anything there. And notice I'm going to recopy the entire problem each step of the way. Okay, so now I'm going to take those 1/2 and I'm going to use the distributive property and distribute it into the parentheses there. So 1/2 times 18x, same as 1/2 of 18x. 1/2 times 18 is 9, so this is 9x. 1/2 times 54 is 25 plus 2, or 27. So I get plus 27. And now I want to begin to use properties of equality to get these terms combined. So because the 9x's are on opposite sides, I'm going to subtract 9x from both sides of this equation, which really simplifies this equation, doesn't it? Because now, and I can do a line down the middle here just to show me the sides are staying balanced. So I subtracted 9x from both sides. So on the left I have x cubed, and on the right I have 27. All right, and we know how to solve x cubed equals 27. We're going to take the cube root of both sides, right? So the cube root of x cubed has to be equal to the cube root of 27. Okay, so now I know, and I'm going to finish over here. Now I know that the cube root of x cubed is x, and the cube root of 27 is 3. So x is equal to 3. Okay, so you might be thinking, wow, we were lucky that it simplified down like that. But in this lesson, all of these problems are designed to simplify down to either x squared equals some number or x cubed equals some number. So if you're working an equation in this lesson and it doesn't simplify to that, that type of thing, then you may have made a mistake along the way, or it's not fully simplified. So later on you'll have the skills to solve an equation of this type without it simplifying down. But these are specially designed because this is the skill that we have for solving these equations with exponents on the variables. Okay, so let's move on. So example 2, oh wait, we forgot something. I just realized you can't forget, you can't forget the checking step, right? Put x equals 3 into that equation and check it. So the original equation was x squared, or x cubed, plus 9x is equal to 1/2 times 18x plus 54. Okay, so we're going to put 3 in, and we'll get this expression. 3 cubed plus 9 times 3. And I want to know, is that equal to 1/2 of 18 times 3 plus 54? Okay, so 3 cubed is 27. 9 times 3 is also 27. So it looks like on this side we have 54. And I'm saying, is that equal to 1/2 of, now 3 times 18 is 30 plus 24, so it's 54 plus 54. Okay, well 1/2 of 54 plus 54 is also 54. So they're equal, and our equation checks out. Okay, so let's look at example 2. Again, I would encourage you to pause the video and try it on your own before watching me work it out. Okay, so with this one, again, we've got some parentheses here and variables in the parentheses, so we want to distribute this. So my first step is going to be to distribute the x into that parentheses. So the first term will be x times x, and x times x is x squared. The second term is going to be x times 3. So x times 3, we'll write it like this with a coefficient, 3x, which is also 3 times x, or multiplication, right? So x times 3 becomes 3x minus 51, and that is equal to negative 3x plus 13. All right, so now, switch colors. So I notice I have a negative 3x on both sides of this equation, so I want to get rid of that term, and I can do that by adding 3x to both sides. So negative 3x plus 3x becomes 0 on both sides of the equation. So we're just left with x squared minus 51 is equal to 13. Okay, and so since I'm trying to solve for x, I want to get that x squared term on one side of this equation. So to do that, I'm going to add the 51 to both sides. And once I do that, I just have x squared on the left, and that equals 64. Okay, so if x squared equals 64, then the square root of x squared is equal to the square root of 64. And square root of x squared is x, square root of 64 is 8. Okay. Now, since we're just solving an equation and we want to know what values will work in this equation, we can take into account the negative values too. And the way we're going to do that is when we do the step where we take the square root. Let me back this up a little. When we do the step where we take the square root, we're going to add a little something. Let's see if I can pause here. What we want to do is, when we do this, we can put a plus or minus there, and what that means is that that's showing two solutions, that x can equal 8 or x can equal negative 8. And we talked about this in an earlier lesson. When I have an equation like this, x squared equals 64, if I put 8 in for x, it will work because 8 squared is 64. But I can put negative 8 in for x, and that's going to work too, because negative 8 times negative 8 is also positive 64. So this becomes two solutions to this one equation. All right, so let's go ahead and check those, because I think that's really going to help us. So what I want to do first is rewrite this equation. So I've got x times x minus 3 minus 51. Because when you check your work, you always want to go back to the original equation, negative 3x plus 13. So that's my equation. Now we're going to check two solutions. So I'm going to make a copy of this. Let's see if I can do this. I'm going to make a copy, and we're going to check both solutions. So first let's check x equals 8, and down here we'll check x equals negative 8. All right, so for x equals 8, we're going to have 8 times 8 minus 3 minus 51. And we're asking ourselves, is that equal to negative 3 times 8 plus 13? So this becomes 8, if I do what's in the parentheses, 8 times 5 minus 51. And again, is that equal to negative 24 plus 13? So we've got 40 minus 51. So that's going to be negative 11 on this side. And over here, negative 24 plus 13, we need to subtract. And, excuse me, subtract, and it's going to be also a negative number, so negative 11 on that side of the equation. So x equals positive 8 checks out for that equation. So now we're going to check x equals negative 8. So now we've got negative 8 times negative 8 minus 3 minus 51. This is way harder than solving the equation in the first place, isn't it? And then over here, well, we know, okay, this is negative 3 times negative 8 plus 13. Okay, so we want to know, are these two things equal? So that's a question, right? So now we've got negative 8. Now what's in the parentheses here? Negative 8 minus 3. If you're still struggling with positive and negative numbers, I would really recommend going back to the number line. I'm at negative 8 and I subtract 3. I end up at negative 11 on the number line. Minus 51. And over here, we've got negative 3 times negative 8. Now this time I've got positive 24 plus 13. Okay, so what do we have here? We've got negative 8 times negative 11, so that's 88 minus 51. And over here we've got 24 plus 13, which we can now see is 37. And 88 minus 51 is also 37. So 37 is equal to 37. So there you go. So there's an equation. Now the equation, remember we used to solve equations and they only had one solution. So now we're solving equations and they can have two. And that's because of that x squared term. Okay, so both of those answers checked out. So pretty cool. You should always check your work on these. But I know sometimes we make mistakes checking the work, so that becomes a problem. All right, so exercises 1 through 7 you could do independently. You're only asked to find the positive value of x that makes each equation true. But if you'd like to find both and check both, you're more than welcome. Convince yourself that both of those values will work for x. So go ahead and solve these. Either check them one by one with the video or check them all at once when you're done. All right, for number 1, I'm going to start by rewriting the equation over here. X squared minus 14 is equal to 5x plus 67 minus 5x. Okay, so I was like when I start an equation just to see what terms I have. Now there's no parentheses here, so I'm good to go. I have x squared, and there's a constant term, and then here's an x term, another x term, and another constant term. So I know I'm going to be combining the x terms and combining the constant terms in this equation. And so first thing I'm going to do is just work on one side, and that'll be the right side. So x squared minus 14 is equal to 5x. Now I'm going to think of this as plus a negative 5x, right? So that I can move things around. So this will be 5x plus negative 5x plus 67. Okay, so I just use the commutative property to get those two terms together. Not really a necessary step, but when you're just getting going, it helps. X squared minus 14 is equal to, now 5x plus negative 5x is 0. So this is just 67 on this side. So now all I've done so far is just simplify the right side of that equation. So now I'm going to use properties of equality. So I'm going to add 14 to both sides. I've alternated my coloring scheme. That's okay. So x squared minus 14 plus 14 is just x squared. And that's equal to 67 plus 14, which is 81. Well, that's convenient. So I'm going to take the square root of both sides. And I can see here, and this will be plus or minus, but remember, we're just finding the positive value, so we'll just leave that off. The directions specifically said the positive value, so the radical sign or the square root is the positive value of that. So this is square root of x squared is x, and the square root of 81 is 9. So x equals 9 is the solution to that equation. And we can come up here and check it. We can put in 9 for x, we get 9 squared minus 14, and I'm checking if that's equal to 5 times 9 plus 67 minus 5 times 9. So I've got 81 minus 14 over here, and I've got 45 minus 45 plus 67, so this is just 67, and so I get 67 equals 67, and it checks out. It says explain how you solved the equation. We could say let's get a different color. We first simplified the right side of the equation. For simplified the right side, we used properties of equality. Then took the square root of both sides. Which is really just another property of equality, right? It's just a different one that we can use. And then we saw that x equals 9, or something to that effect. Okay, number 2. If you haven't done it yet, you can go ahead and pause and work on that. Where's my equation? I've got x, times x minus 1 is equal to 121 minus x. All right, so let's look at this. So x times x minus 1, I'm going to use the distributive property and simplify that. X times x is x squared minus x times 1, which is x. And that is equal to 121 minus x. So now using properties of equality, I can add x to both sides because I want to get all like terms together. So I've got those x terms, I've got constant, and I've got x squared. So this leaves me with just x squared on the left-hand side, and on the right-hand side, it leaves me with 121. Okay, and then I have the square root of x squared is equal to the square root of 121. So x is equal to 11. And once again, now this doesn't just say positive, so plus or minus 11. So x can equal 11 or x can equal negative 11. Those are my answers. So you would want to check those and make sure that they are correct. And I think we've done enough of that on the video. You can, if you need help, want more experience with checking those answers, then you could look in the full version of the teacher notes. But I think you're good with that. We'll go with that. But you should check every one of these answers just to make sure. All right, number 3 looks a little different. It's not just an equation. We're going to have to write an equation for this. But a square has a side length of 3x and an area of 324 inches squared. So let's go ahead and draw a diagram. Side length is 3x and area equals 324 inches squared. What is the value of x? All right, so what do we know about area? We know area is length times width. Since this is a square, all of the dimensions are 3x. So we have area is equal to base times height, or length times width, whichever one. So we know the area is 324. And we know the length and the width are both 3x times 3x. So 324 is equal to, I'm going to separate these apart. This is 3 times 3, and this is x times x. And I can associate them. Since everything's being multiplied, I can group them however I want. So what we have here is 324 is equal to 9x squared. And so my next step, I might have to go into 2 columns on this one. My next step would be to divide by the coefficient of the x squared term so that I can get x squared by itself. And keep picking the wrong tools. So then this 324 divided by 9 is 36. And 9 divided by 9 is 1, so this is just x squared on this side. So since we're dealing with a geometric figure, we know that there's not going to be a negative solution. So I'm going to continue this up here. So I'm going to say that the square root of 36 would equal the square root of x squared. Square root of 36 is 6. Square root of x squared is x. So x is equal to 6. Okay, so if x is 6, then the dimensions of that figure are 18 times 18, which you can check out and find is 324 inches squared. Okay. Okay, exercise 4. We've got negative 3x cubed plus 14 is equal to negative 67. So, since I'm working toward, the only term that has a variable in it is my x cubed term. So I'm working toward getting that by itself. So I'm going to do that by subtracting 14. Whoops. Subtracting 14 from both sides of that equation. And that leaves me with negative 3x cubed is equal to negative 67 minus 14. So I'm getting more and more negatives. So this is negative 81. Okay. So I want x cubed by itself. So to do that, I need to divide by the coefficient of x cubed. Divide by negative 3. And I'm going to rewrite that. I'm going to get x cubed, that's 1x cubed, is equal to positive 27. And then when I take the cube root of both sides of that equation, cube root of 27, then I've got, cube root. Cube root of x cubed is x. The cube root of 27 is 3. So x is equal to 3. So we go ahead and put that in. And notice that there isn't another solution for this one, because if I make it negative 3, then it's going to be negative 27. So that won't work. So I've got negative 3 times 3 cubed plus 14 equals negative 67. So negative 3 times 3 cubed is negative 3 times 27 is negative 81 plus 14 is equal to negative 67. And negative 81 plus 14 is the difference between 81 and 14. And it's a negative number, so this one checks out. Negative 67 equals negative 67. Okay, so number 5. Okay, this next problem, problem 5, has 2 sets of parentheses that we need to distribute. So we're going to have x times both of those terms, and here we're going to have 4 going in here. So x times x is x squared. X times 4 is 4x, and I have minus 3, and that equals 4 times x, which is 4x, plus 4 times 19.5, 19 and a half. So that would be 4 times 20 is 80, and then I would subtract 4 times 1/2 from that. So I would get subtract 2 from 80, I get 78. You can multiply that out if you're not sure about that. Okay, so now I've got this equation with some x terms, x squared, and some constant terms. So I need to get those combined with each other. And let's start with the constant term. So let's add 3 to both sides. We can actually do 2 steps at once here. We'll add 3 and we will also subtract 4x. Subtract 4x from both sides. So you can do those in 2 steps, but you can also do it in 1. All right, so 4x minus 4x is 0. And negative 3 plus 3 is 0. So on this side, what is that side? The left-hand side, all I have left is x squared. And on the right-hand side, 4x minus 4x is 0. 78 plus 3 is another one of those perfect squares, is 81. So square root of x squared is equal to the square root of 81. So x is equal to 9. Okay, and we've been asked to find only the positive root and to check our solution. So let's do that. I'm going to use the original equation right here, and I'm going to put 9 in for x. So I'm going to get 9 times 9 plus 4 minus 3 is equal to 4 times 9 plus 19.5. So now I have 9 times 13, and that's 90 and 27. So that's 117. Right? Did I do that right? 117, I think so. Minus 3. And over here, I've got 4 times 19.5 plus 9. Or 4 times 28.5. So over here I've got 114. So if 4 times 28.5 is 114, I'm good. So 4 times 30 is 120, minus 8 is 112 plus 2. Yep, 114. Okay, here we go. And then number 7, which should be fun. All right, so we've got some parentheses, so let's deal with it. 216 plus x is equal to, now I want to distribute this. So we've got x times x squared minus 5x times 5, which is 5x. And then I've got plus 6x still. Okay, so let's straighten out the right side before we move anything around. So x times x squared is x used as a factor 3 times, so that'd be x cubed, right? I also can use my exponent rules and just add them. 2 plus 1 is 3. Now I've got minus 5x plus 6x. So now I can combine those two terms. I've got a negative 5x and a positive 6x. So I've got 216 plus x is equal to x cubed. And then negative 5x, positive 6x, will be negative 5 plus 6, which is 1. So this is just plus x. Right here. So now I've got both sides simplified. This is a really good technique to keep from making mistakes. Notice I'm not using any properties of equality until I have the equation in a form where it's most simplified. Meaning on both sides of the equation, I've combined all like terms. Now, I can, I want to isolate that x cubed. So I'm going to subtract the x terms off. And remember I said these are special problems. They wouldn't normally cancel from both sides, right? But I'm getting it down every time to this form of x squared or x cubed is equal to some number. So if 216 is x cubed, then the square root of 216, cube root, is equal to the cube root of x cubed. Cube root of x cubed is x. The cube root of 216, I believe, is 6. 6 times 6 times 6 is 216. So we have x equals 6 here. And I am going to leave that one to you to check, but you should come up with 222 is equal to 222 when you check that one. Okay, last one. I like this one. It says, what are we trying to determine in the diagram below? we need to determine the value of x, right? And we're going to determine the value of x by using the Pythagorean theorem. So that's what we're trying to figure out. And so to determine the value of x, I'm going to come over here and just work in this space here. So I know for the Pythagorean theorem that a squared plus b squared equals c squared when a and b are the legs and c is the hypotenuse. Okay, so I've got 4 times the square root of x is one of the legs, so I need to square that. And 5 inches, now these are all in inches, so I'm going to leave the units off. 5 is the other leg, so I've got 5 squared, and that's equal to the hypotenuse squared. Okay, so 4 times the square root of x squared. To square a number, I just do 4 times the square root of x, use it as a factor twice, multiply it by itself. Okay, so now we've got that. I just took the square of both of those terms over there. So 4 times the square root of x times 4 times the square root of x, I can move the factors around, right? Because I can do them in any order. Times the square root of x times the square root of x, and then plus 25 equals 121. All right, so what is 4 times 4 is 16, and the square root of x times the square root of x is the number x, right? Because it's the number that multiplied by itself to get x. So square root of x times the square root of x is x. So I've got 16x plus 25 is equal to 121. So I've not used one single property of equality yet, but I'm going to now. I'm going to subtract 25 from both sides of that equation. And on the left, I'm going to have 16x. And on the right, I'm going to have 121 minus 25, which is 96. Could do the subtraction. And now, notice I don't have any squared terms in this anymore, but I just need to solve for x. Divide by 16, and I get x is equal to 6. There. Okay, so the length of that side is 4 times the square root of 6. All right, so this lesson is going to give you lots of practice with solving equations. That's the main thing here, really. You will have to use what you know about cube roots and square roots at some point in solving these. That's over here. This is the checking step. So you will need to use a square root by, solve for x by taking the square root of both sides. Or taking the cube root of both sides if it's x cubed equals p. Okay, good luck with that, and I encourage you to do any review that you need to do to be successful. It might be adding and subtracting positive and negative numbers. It might be those properties of equality, or combining like terms, or any of those things. So those are all things that you can hop on Khan Academy and watch some quick videos for, or call me, and we'll do a quick lesson. All right, good luck with lesson 5.